students, welcome back to your favorite YouTube channel Science with Mukherjee sir. Myself K.K. Mukherjee. Today we are going to discuss how the catalyst is going to influence the rate of reaction. The catalyst, you know, that is basically influence the reaction in terms of giving the higher rate of reactions. How catalyst is going to influence the reactions, that we are going to discuss in this video. Catalyst is a substance that is going to increase the rate of the reactions. As for example, if we take the example of KClO3, in normal temperature the decomposition rate is very less, but when we give some catalyst MnO2, its decomposition rate is very high. So this is the reaction, and it is here you can see this is the catalyst. So catalyst is the substance which is going to increase the rate of reaction. And question arises, how the catalyst is going to influence the rate of reactions? How the mechanism of catalyst increase the rate of reaction is basically, it never changes itself. We can write the catalyst is substance going to increase the rate of reaction without changing itself. There is no change basically in the catalyst. So how they do that? It has been proposed, it has been believed that they are going to make a temporary bond with the reactant molecules. So they are going to make a temporary bond. So we can write, they are going to make catalyst. Catalyst is going to make bond with the reactants molecule. And this is basically the transitory phase. It is not a very permanent phase. So with this creating an intermediate complex, and it makes the intermediate complex. How they do? Basically, they are going to decrease the activation energy by rearranging the reaction path. And that we can understand from this curve. This is the energy in y direction, and the x-axis, the reaction coordinate. It is basically going to give the energy profile of the reactant at the bottom. So we can write this is a reactant R, and this is a product. So here you can see the activation energy is this. This amount of energy is required for going out, for making the reactions. This is called the activation energy, EA. it has become as EF. Now, this is without catalyst. Now, when catalyst is added, the reaction path is believed to be changes and it will be like this. So, you can say in this case, suppose the activation energy EA when we are using the catalyst. So, you can easily see the activation energy has been decreases, and that is how they are able to increase the rate of reactions. So, we can write that catalyst So, catalyst is going to decrease the activation energy by making a new activation, new reaction path. That is how catalyst is going to. It is believed that catalyst is on the process in the reaction, or they are do like this way. But there is some points that you must remember. That is number one point, that catalyst do not change the free energy del G, that is free energy change of the reaction. We know free energy change, that is gives energy. Catalyst does not change the del G. The reaction will have its own del G, that catalyst has nothing to do with the del G. Number two, catalyst for reversible reaction influence both the direction. Influence both the direction. Right? Number third point, it do not change the equilibrium point. Catalyst do not change the equilibrium point. Catalyst do not change the equilibrium point. Equilibrium point. It helps to achieve, it helps to bring the equilibrium at a much faster time. And last, catalyst never acts in a non-continuous reaction. Never acts in the non-continuous reaction. Because if the reaction is not continuous, at that time catalyst is nothing to do. Catalyst will not going to influence the reaction. So this fourth point you must remember, that is catalyst do not change the del G, that is free energy change. Catalyst for reversible reaction influence both the direction, that is reversible reaction and the backward reaction. Catalyst do not change the equilibrium point. It will help to reach the equilibrium point at the most faster time. Catalyst never acts in a non-spontaneous reaction. And that is what we should learn the catalyst, about the catalyst, that is in your syllabus, and you should learn this. Okay. Now we go to the very important thing, that is the collision theory. So now we are going to discuss the collision theory. Arrhenius equation is a very good concept and is giving the good equation that can be applicable to a wide range of circumstances. But two scientists, Trautz and Lewis, two scientists, and Lewis, they proposed one important theory which gives us a much more insight into the energetic and mechanistic view of the reactions. Trautz and Lewis gives a very energetic and mechanistic view of the reactions. They propose that reaction is going on the basis of the collision, and every reactant molecule is a hard sphere, incompressible sphere that they are assuming. And they have given a very important concept, that is the collision frequency. So we can write the collision frequency. That has been represented by Z. What is that? This is the number of collisions. This is the number of collisions This is the number of collisions per unit volume and unit time. And you can understand, and we have discussed in detail in the previous video. If you have not observed that video, if you have not watched that video, you must watch that video. In that video it has been discussed in detail that all the conditions that is going to take place during the reaction is not going to yield the product. Those conditions will going to be give the product. We can say product producing conditions. We can say product producing conditions. They are basically those conditions which is having the higher energy equal to or more than the activation energy. So energy of the condition which is having more than the activation energy, equal to the activation energy or more than this, will going to produce the product. So we can write for a reaction, suppose JAB is the collision of the frequency of collision, frequency of collision. So we can relate this collision frequency, how that has been given by Trautz and Lewis. They say rate is basically that JAB into e to the power EA by IT. What is EA by IT? EA by IT, this factor we will say the proportion of the molecules having the higher energy equal to the activation energy of higher energy proportion. So rate is equal to JAB, that is the total collisions, total frequency of the collisions, and this is given by this. And if we compare with the Arrhenius reaction is K is A into e to the power A by RT. So we can say this A factor is basically the collision frequency. That is why A is called the frequency factor, the frequency of the collision. So we can relate this. Now, if we go by this equation, you want to calculate the rate constant, we can able to do that, and that will give a very good correlation and good close to what we have get from this Arrhenius law for the simple reactions. But when it is complex reaction, it do not have much of the, there is a lot of deviation you can see. Now question arises, why it is so? Then another factor comes, that is the orientation. If the molecule having the higher kinetic energy, that is equal to the activation energy or more than this, in spite of this fact, if it is not oriented properly, that it will not going to create the better result. How it is so, that we are going to understand with some example. This is a production of the alcohol, methyl alcohol, from the methyl bromide. When this OH molecule is like this way, OH ion, let's say, OH ion, not molecule, if it comes in this way, what is going to happen? No product will be there because this orientation is not appropriate. No product. So we can say orientation not proper, improper orientation. We can say it is improper orientation. Okay, improper orientation. Now for the second case, you can see this is intermediate and product is formed. This orientation with the reactant molecule, we will say that is a proper orientation. Proper orientation. So what is there? Maybe this OH molecule or this molecule having the higher energy is very high. It's more than the activation energy, but they will not going to produce the product because of this improper orientation. So another factor comes. This factor is called the mobility factor or the steric factor. So we can write this further modify this equation. Rate is equal to P into J AB e to the power minus EA by RT. And P is here is steric factor. Steric factor. Or we can say probability factor. Another name is here probability factor. Probability factor. So you can understand that when we are going to make the reaction successful, when there is a good effective reaction is going on and we are producing the product, at that time, these two things that we must remember in mind, that is the activation energy. Number one, that is activation energy. Activation energy. And number two, the effective collision. Effective collision. So this is two things that we need to understand. I think it is clear to you. So that is all for this video. If you like this video, you can share to your friends and you can subscribe accordingly. So next video we try to understand more things about the chemical kinetics. Till then, all the best and be best.